Hello, welcome to Everything Distributed. Today, we are going to talk about hash pointer and tamper-resistant log. And the content is based on a very nice note from Rutgers in chapter 1 in BCT, Bitcoin and cryptocurrency technology. So what is a pointer? From Wikipedia, pointer is a very useful object or very useful design in many of the programming language that tells you where your value is stored. It's called memory address. So in this figure, you have variable called num1, which has a value 15, and the pointer to the variable is that I say in C is that you have n sign of num1, and then in your computer, it's a physical address to some memory address. So that's a pointer, tell you where your value, where your variable is stored. But in distributed system, because that typically you cannot directly access the memory address and the other computers. So what we mean by a pointer in this case is that it's an ID or its IP address. And then here, of course, we need to assume that there's a unique ID for some object or some other entities. Otherwise, that there's some ambiguous of like what a pointer points to. So in this case, from now, we assume that there's a unique ID. And when we say a pointer, we just say that, okay, by looking at the pointer, I know where to find the stuff, or then it could be an object, or it could be other nodes or some IP address that the pointer points to. Now, I want you to recall a very useful data structure in computer science called linked list. And the idea is very simple. You have some data structure, and then you have pointer that links different element, different data together. And from Wikipedia, again, it's a linear collection of data elements. And then if you recall what you have learned before, then you will say that, okay, each element in this list has like two components. The first is a value. In this case, it's an integer, and you have a memory address, a pointer point to the previous item, and then the end or the head, depending on how you define it, point to a null space. Okay, so that's how you define a linked list. It's very simple. And the key benefit is that it's very easy to add or remove elements. Then actually it's also very useful in distributed system once we consider the idea of pointer in distributed system. Then blockchain actually is nothing magical. You can think of it as a linked list, a special type of linked list. And if it makes more sense, it's just a chain of blocks. And one key component that we want to ensure is the property called tamper-resistant or tamper-evident. In a sense, is that we have a log where log could be in any type of log, but like here, let's say it's a linked list. Then we want the element that's stored inside the log, it shouldn't be tampered with. And then if something is bad happens, some adversary tampers the element, then me, the owner, should be able to detect it. Okay, so suppose I have a linked list and then say store in my computer, and some bad person come here and then replace this element with like 24. Then now let's assume that every element can be modified. Of course, there's nothing I can do. So the goal of this kind of tamper-resistant log is that I want to store a very small piece of data that's just in a secure storage. They said that in my special disk that no one can access besides me. Okay. Then I want to make sure that the data stored there is very small, so that's very efficient, it's scalable, and then I can detect whether some tamper has occurred or not. And in this case, what would be a trivial solution? The idea is very simple. I store everything inside my secure storage and no one can tamper it. but of course, it's not very scalable. So what do we want to do? And here is one of the key component in blockchain of Bitcoin. It's that I use a linked list where like originally it uses a pointer, but now I need to use the idea of hash pointer. So what's a hash pointer? It's nothing magical. It's an idea of pointer and plus the hash value. Okay. So now your data looks like this. It's also very similar to linked list, but right now hash pointer has two fields, one the hash value and then your pointer. So this is the original block. You have block some data, you have hash pointer 0, point to nothing. And then the next one, how do I link this data to the previous one is that in this hash pointer one here, I have two elements. The first element is the hash value of the previous block. And I also have a pointer that tells you the identity. Remember that we assume such that each element or each block in this case has a unique ID. So that's the meaning of this arrow. And then that's the whole data structure of your blockchain, which is a linked list, and which uses a hash pointer to link them together. So in this case, suppose I want to achieve the goal. I want it to be tamper-resistant or tamper-evident. What data do I need to be stored to make sure that this thing, block 0, block 1, block 2, is secure, is tamper-evident? In this case, actually, I only need to store head, which is a hash pointer 3 in this case. So why is that? Suppose a bad person come here and say that, hey, you know what? I'm going to tamper the value stored in block 1. And now it becomes block 1 prime. But in this case, you go back to your disk, you will find out, hey, something's not right. Because if I do a hash again, then remember what's hash pointer? In hash pointer 2, there's a hash. That's the hash of the previous block. Then I will do hash block 1 prime. Then these two things, they won't match. So I know I catch the tamper. Okay. Then the bad guy said, oh, okay, if you can catch it, let me do one more step. I try to change the value of hash pointer 2 to hash pointer 2 prime so that it match the previous hash point, the hash value, and also the value of block 2. But does this work? No, right? Because remember this green thing, this green hash pointer actually is secure. No one can change it. Then the hash value won't match what you have here. Okay, so that's the power of hash pointer. That let you detect something bad has occurred or not. Then we have this idea of a blockchain, which is just a linked list with a hash pointer. Then when we say the data in block, actually it's a set of transactions. And to make it very efficient to query to add something, then we use Merkle tree. So that here, block the data in block 0, data in block 1 as Merkle tree. Merkle tree contain transaction. And then we link them together so that the log or the list is tamper-resistant. And then why this is useful, because that we know exactly what the transactions are when you look at block 0, block 1, block 2, and everyone will have the same thing. And then this thing will also have the same ordering of transactions. So remember how we use money? The ordering of transaction is actually very important because that tells you whether one transaction is valid or not, or who owns the money of this certain transaction. So the big questions that we are going to start next is that, okay, we know the data structure, we know the blockchain, we roughly know that how to use Merkle tree, but who gets to decide which block to be included to, and then how to form a block, and what's the ordering of block, and then that's where consensus is used inside Bitcoin or in many blockchains. So that's all for today. two idea I want you to think about or to take away is that what is a hash pointer and why hash pointer is useful to achieve this temper resistant property. That's all. Thank you.